Let's have a look at the second problem that appeared on the paper. Okay, a student throws a ball towards a wall. The ball is released from a point 1.8 meters above the ground. That's shown here, 1.8 meters, and 8 meters from the wall. So the horizontal distance separating the boy and the wall is 8 meters, as is shown here. The initial velocity of the ball makes an angle of 48 degrees with the horizontal, shown here. Air resistance is negligible. That's good. The diagram shows the initial path of the ball. P is a point on the path. So P here is a point on the path which the ball travels. Let's move on to the question. Part A. Draw on the diagram an arrow to show the velocity of the ball at P and label this arrow V. Okay, that's one. Number two, the acceleration of the ball at P, and we need to label this arrow as A. Well, whenever an object moves, the velocity at any point on its path is just a tangent to the curve. So we are supposed to draw a tangent to the path and call that as V. So the velocity vector is always a tangent to the path. So that completes the first question. The next one says that we need to draw the acceleration vector. We should keep in mind that the only force that the ball has when it flies through the air is due to gravity. And gravity only points downwards. If the net force is downwards, the acceleration has to point downwards. So we'll draw a vector for acceleration that goes vertically down and label this as A. In fact, this acceleration is the same as the free fall acceleration, which is equal to 9.8 meters per second square. So that fetches us 2 points. Let's move on to the next part. The ball takes 1.3 seconds to reach the wall, and show that the initial speed of the ball is about 9.8 meters per second. All right, let's have a look at the figure. So when we throw the ball, let's clear this, and the ball moves on this path and it hits the wall, the time it takes is 1.3 seconds. Okay, so its initial velocity at the point of the launch would look like this. Initial velocity vector would go this way. Let's call that V. And the horizontal component of this velocity would be V cosine 48. So the horizontal component of the initial velocity vector is V cosine 48. We should keep in mind that this horizontal velocity is constant because the only force is vertical, the only acceleration is vertical, so only the vertical component of the velocity will change. The horizontal component just stays the same. All right, so the object moves with a constant horizontal velocity of V cosine 48 and it covers 8 meters in 1.3 seconds. We can simply use the equation distance traveled or velocity, horizontal velocity, it's equal to the horizontal distance covered divided by the time it took to cover that distance. And Vx would be V cosine 48. The horizontal distance traveled is 8.0 meters and the time it takes is 1.3 seconds. If we solve for V, we get V equals 8.0 divided by cosine 48 times 1.3. I leave this as an exercise for you to try. You'll see that it's about 9 meters per second. And that solves this part of the problem. Next up, we are supposed to find the height above the ground at which the ball hits the wall. So if we go back to the question, they are asking us to figure out the vertical height. So if the ball travels along this path and it hits the wall, they want us to figure out this vertical distance. Let's call that h. So how do we solve this part of the problem? Well, we can use SUAT equations. Let's use SUAT equation along the vertical axis. Let's use this one. S equals ut plus 1/2 at squared. So we know acceleration is minus 9.8 meters per second square. Time we know it's 1.3. That was given to us here. So we know the time, we know the acceleration, but what about u? Here we have to be careful. Since we are focusing on the vertical axis, we want to take the vertical component of the velocity. The vertical component of the velocity would be v sine 48. So u can be written as v sine 48. So we can plug all these values a, t and u into this equation and solve for the displacement. So we should write S equals v sine 48 times time, which is 1.3, minus half times 9.8 times 1.3 square. The value for v we're going to use is what we found out in this part of the problem, that we should substitute that here. Mind you, when we find the value of s, this gives the displacement from this point. It gives us the height of the object of the ball from this reference point, this to the top of the wall. But we are supposed to find the total distance from the ground up to the wall. So we need to add 1.8 meters to s in order to find the total displacement. I leave this as an exercise for you to try, and you'll find that completely solves this problem. If you need more help, I teach one-on-one classes. Feel free to reach out and I can help you get a perfect score. I'll see you in the next one. Bye-bye.